So you just learned about the general way that atoms are arranged in metals. Remember, the sea of electrons forms this negatively charged medium, and it pulls together all of the positively charged cores like glue. That's the atomic structure of metals. In this lesson, we're going to be taking a look at the properties that atomic structure causes. What are metals like because there's a sea of electrons with positively charged cores evenly arranged within the sea? Let's take a look at the properties of metals. What we're going to do in this lesson is envision metals as positively charged cores with electrons around the outside. But those electrons are delocalized. They're free to move around between the cores, and therefore we end up with a bunch of positive cores within a sea of negatively charged electrons. And that gives these substances, these metals, some interesting properties. For example, if you were to take a metal and pound on it with a hammer, you would find that these cores, these positive cores, are able to move fairly easily within the sea of electrons. They just move to a new spot and rearrange themselves to evenly spread out within the sea, and they make a newly shaped crystal. We call that malleability, the ability to pound metals into a new shape, especially into flat sheets. When you pound a metal, all that happens is the positive cores are rearranged in the sea of electrons. It doesn't break it apart or shatter it or even turn it into a new substance. It just moves the cores around. Another thing related to malleability, by heating metals up, you can draw them into thin wires. And the reason that works again is because all you're doing is moving the positive cores within that sea of electrons to a new location without shattering the substance to pieces. So that's one of the really cool properties that metals have, is that you can pound them and shape them without destroying them. Speaking of ductility and wires, let's take a look at what happens if you run wires to a metal and attach those wires to a battery. Here's another property that metals have because the electrons are free to move. Metals are great conductors of electricity. And what that means is the electrons are free to slide between the atomic positive cores and move from one place to another when you apply an electric current. And it's really easy for the electrons to just slide around in the sea of electrons and move from one place to another. Now, it's important that you still have the same number of electrons. You have electrons flowing out and electrons flowing back in. They're just not tied to specific atoms, and that makes metals great conductors of electricity. Another property of metals that's really important has to do with how light behaves when it hits a metal. Now, light is made up of electromagnetic waves, and electromagnetic waves, remember, are made up of energy, not matter. When electromagnetic waves hit an object, they interact with that object a certain way. Like, for example, if these electromagnetic waves of light hit a piece of paper, notice this paper is white, the color white means that all colors are being reflected by that substance, and you're seeing a mishmash of all of the different visible light colors that we can see. However, a piece of paper is white and not reflectively shiny, because when it reflects all of that light, look what happens. It reflects it in a bunch of different directions. It doesn't evenly reflect it directly back the direction that it came from. When something is colored, like this beach ball, what happens is some of the light that hits the beach ball is absorbed into the beach ball, and the color that we see is reflected out of it. So this beach ball appears blue because it's absorbing a bunch of wavelengths of light, but only reflecting the blue light. Now, understanding that is key to understanding why metals are shiny and usually a silvery whitish color. Let's say we're looking at a piece of silver. And actually, let's take a look at the silver at the atomic level. You see, silver has delocalized electrons. It has electrons that are very free to move around. Now, what happens when an electromagnetic wave of light hits an electron that's a part of a silver metal atom? The electromagnetic wave gets absorbed by the electron and gives it more energy. It jumps up to a higher energy level. But these electrons of metals are so free to move around, to gain energy and lose energy. They're not tied to the specific atom. They're able to move so much that it just falls right back down to its original energy level, and it shoots the energy back. The exact same wavelength of light that came in goes right back out the same way that it came from. That's what makes metals reflective. Now, maybe to understand this a little better, it would help if I had more metal atoms and more electromagnetic waves of light. Let's take a look at this crystal structure of a metal and see what happens when we shoot in a bunch of electromagnetic waves. The electromagnetic waves are going to cause the electrons to gain energy, but then those electrons are going to fall right back down and shoot that energy right back out. That's called reflection. And as long as those electromagnetic waves are going the exact same way they came in, instead of being scattered in all directions like the white paper did, as long as they go right back out, that metal is going to appear reflective. It's also going to be shiny if the metal is very smooth. And here's why metals usually appear shiny. Remember, it's easy to move around the atoms in the crystal of a metal. So therefore, it's really easy to pound metal into really flat shapes and to polish it so the atoms all line up perfectly in the crystal. That's what gives metal their shiny quality. So we would say metals are opaque, meaning they don't transmit light through them. They won't allow light to go straight through. They shoot light right back out the way it came. You can't see through a metal because the electromagnetic waves get stopped by the metal and shot back. They're opaque, but they're shiny. There's one more property of metals I want to look at, and that's that they have a wide variety of different heating properties and densities. I'm going to show you an example of a metal that you're familiar with. This is zinc. Instead of just having positively charged cores like sodium did, zinc has higher positively charged cores, 2+ charged cores. It has more electrons in the electron C, and that pulls the atoms in the crystal even closer together. Another metal that you may have heard of, neodymium, has even more electrons in the electron C. Its cores are charged with a 3+ charge, and there's 3 electrons around the outside. This pulls these atoms together different amounts. Now, when a crystal is pulled tightly together by its electric charges, it's going to have more density, and it's also going to be much harder to melt. Hopefully now you understand some of the properties that the electron C and the positively charged cores give to different types of metals. But you should understand what makes metals similar as a group, why they have the properties that they do, because of the sea of electrons and the positively charged cores.